Hey everyone, so I wanted to do something that kind of showed you how we go about using exponential equations and logarithms in real life and an actual application of those. Because I think it's really cool that this is at least one thing that everybody can use regardless of what job you're going into. And granted, there's programs and calculators that you can usually find that will help you calculate it. Um, but this just gives you kind of a broad picture of what's going on. That way, when you look at a bank statement or a loan rate or something like that, you can understand it better. So as you go through this, anything that I've put in bold, just write your answer in for. I said Microsoft Ink, but I'll probably just send this to you in a Smart Notebook file and as a Microsoft document. So you can either type it using Microsoft Editor or you can just write on it. So answer any bold questions, and then you'll be watching these videos to take notes and do all that stuff. So you'll do most of the reading on your own, so I'm going to skip over that part. So go ahead and read all of that. A lot of this, like the formulas and stuff like that, we've already taken notes over. So you should be able just to skim through it a little bit. I just wanted to walk through these examples and have you jot those down. So suppose you started a savings account when you were 5 years old. So these answers will depend upon your current age now. You started it with $100, but you never added more money to it. You just let it grow and accrue interest. How much money is in your savings account now if you are getting a 3% interest rate compounded quarterly? So again, we're using our formula. And so we have our formula here, and depending how old you are, some of you might not even be 16 yet, but 16 years old, then the amount will equal your principal, which is 100, 1 plus your rate, which is 0.03. So usually mistakes happen right there. Make sure you convert that to a decimal, over number of times compounded per year, which is 4, raised to the 4 times, and this is where your time is going to vary. So you were 5 years old when you started it. A 16-year-old, then that would be 11 years. And you can just type that into your calculator carefully, making sure you're using parentheses. I usually use parentheses there too, or go ahead and multiply those. And so the amount that a 16-year-old would have is 138.93. Since we're talking about money, make sure you round that up correctly to the nearest hundredth. All right, a 17-year-old, you would do the same way. With the change of how many years this has been invested. So just a year later, everything stays the same except for that 11 is now a 12. It has been one more year. And so we can type that again into our calculator. And that is, your actual amount would be 143.1. And suppose you started a savings account on your 18th birthday with $1,000. How long would it take to double your money? So we want $2,000. If the interest rate is 5% compounded monthly, so N is 12, and you never added any more money to the account. So remember that them saying that is the reason we can use the account that we have. So we know the actual amount that we want. We want $2,000. We started with $1,000. Knowing that we're 18 doesn't matter. We're looking for the time, how long. So we have 1 plus 0.05 divided by 12, raised to the 12t. And so in this case, we're solving for t. You'll see a couple different ways to do this. I'm going to divide by 1,000. And then I get 2 is equal to, and I'm going to go ahead and make that a number. So 1 plus 0.05 divided by 12. And I don't actually want to write that all out, so I lied. I'm going to keep that like this for now. Base the 12t. All right, so you could convert this to log form. It gets a little messy if you do that, but you absolutely could log base all of this. Keep that value in your calculator as far out as you can to make this more accurate. A better way to do it to kind of keep from rounding right away is to just take the natural log of both sides, or even the log of both sides. So the natural log of 2 is equal to the natural log of 1 plus 0.05 divided by 12 raised to the 12t. And the reason that that's nice to do is because now we can follow our exponent rules and move the exponent to the front. So the natural log of 2 is equal to 12t times the natural log of 1 plus 0.05 divided by 12. Can divide, again, we want this t by itself, so we're going to divide by 12 and the natural log of 1 plus 0.05 divided by 12 on both sides. And then we can just type that in our calculator, and that will give us t. So careful with your parentheses, natural log of 2 divided by parentheses 12 natural log of 1 plus 0.05 divided by 12. Close both sets of parentheses, and we get t is equal to 13.892 years. Right? The further out you go, the better. Okay. But again, the other way you could have done this was back here. Could say log base 1 plus 0.05 divided by 12 of 2 is equal to 12t, and then divide that by 12. Because a lot of you have the ability to type in a different base in your calculator, so that's fine as well. You should get the same answer when you do that as we did the other way. What if you started the same account with $10,000 and left it into the bank until you were 40? So this part we do need to know that we started when we were 18. We're referring to the same question. So instead of $1,000, we're starting with 10,000. We're leaving it in there until we're 40. So we're leaving it in there for 22 years. This is your principal amount, and we don't know the current amount. We're finding how much money we have now. So A is equal to 10,000 times 1 plus 0.05 divided by 12. None of that changes. Raised to the 12 times 22. That's the difference here. And we just type that in our calculator, and we'll have our answer. All right, so A is 29,973 and 8 cents. A good chunk of change without adding any money to it. All right, so I want to talk to you about annuities. So annuities are insurance contracts that make regular payments to you either immediately or at some point in your future. There's several different types of annuities, and each of them works a little different. You can purchase an annuity to help grow or protect your retirement savings or provide you with guaranteed income. And so the formula for annuities is a bit different. Um, you have your annuities amount, so A sub n is equal to D times the quotient of 1 plus I to the n minus 1 over I. A sub n is the amount of money in your account after n periods of time. N is equal to years, which is different because up here T was the number of years, multiplied by 12 because there's 12 months in a year. So it's number of months essentially in that many years. I is equal to the interest rate divided by 12. So again, we're splitting that up by month because that interest rate is for the whole year. And D is the amount you're depositing each month. So we are contributing a set amount each month, which you typically do with some sort of retirement fund. And so this example, we'll go back to the example when you were 5. You started that account with $100, but this time we're going to contribute $10 a month. So remember that example says don't add anything every month until you're 18. How much money do you have now, assuming it still gets 3% interest? Okay, so for this one, you're depositing, so D is $10, so 10. N, remember, is the number of years, so it's been 13 years. 5 to 18 is 13 years, times 12 for how many months are in a year, so 156. And I is your interest rate divided by 12, so 0.0025. Again, converting your interest rate to a decimal. And so then we plug all of this in. So 10, and we have 1 plus 0.0025 raised to the 156 minus 1 divided by 0.0025. As long as you're careful, you should be able to type all of this stuff into your calculator, but you have to type it in using lots of parentheses. So when I type it in, I do 10 parentheses, and then I do parentheses again. So I'm going to box this whole top part in by a parenthesis. And so I'm going to do a third parenthesis. So your screen looks really weird because you do have 1, 2, 3 parentheses in a row. And I have 1.0025. You can go ahead and add those together. Parenthesis raised to the 156 minus 1, close one set of parentheses, divided by 0.0025 and close my last set of parentheses. And so this account has 1905.05 in it, which, if we go back to the one where we were 5, is a lot more by just adding that $10. And granted, we're talking 18 years old, so we would have a little more than 143 in there, but that's a lot more. So how much did you actually put in? Well, I was contributing $10 a month in addition to the $100 that I started with. So 100 plus 10 times how many months that there were. And so 13 years, 12 months, 156 So 1660 of that is money that you put in. And then how much interest did you earn? We're going to take our final balance and subtract what we put in of our own money. And that will give us what the remainder was, which would then be the interest. So earned a total of $245.05 in interest. And I need to fix this because I forgot to add on, realizing it down here, that I didn't add on the $100 that I initially had onto that. So let's make this 2005.05. So earned 345.05 in interest. I apologize for that. All right, so I have how much I earned in my annuities, but I also had my initial amount that I need to add back in there. Okay. Last example for this video. So you have a really good job and can afford to put $500 a month into an annuity with 5% interest. After 8 years, how much money do you have? How much have you put in, and how much interest have you earned? So same thing, essentially. You know that your D, we're starting with nothing though this time, so I won't make that mistake, forget to add that. Your D is how much you're contributing per month, so we're putting in $500 a month. Your N is how many years times how many months would that be? So we're doing 8 times 12, 96. And then your I, we might have to leave this as a ratio, but our is 0.05 over 12. If that decimal is really long, so I'm going to leave it like that. All right, and we just plug everything in. So we have 500, and then we have 1 plus 0.05 divided by 12. That is raised to the 96 minus 1 divided by 0.05 over 12. And so once again, we can type that all in our calculator. I would, leaving that as a ratio, add that extra layer of parentheses in there. You can never really have too many parentheses to separate things. So again, I do 3 parentheses there, raised to the 96 minus 1, parenthesis, divided by, parenthesis, 0.05, divided by 12, parenthesis, parenthesis. Okay. And we get 58,870. Please practice typing that in your calculator before you do the problems on your own. All right, so that is how much money that I would have saved up. How much money I put in? I put in 500 times 96. So I put in 48,000 of that myself. And so the interest is this one minus this one. So we get 10,870.26 in interest. That's a lot of interest. Okay, and that is it for this video. You're going to complete these problems on your own. Make sure you show your work. And by show your work, I'm talking like the same thing I did. All right, write out essentially all of the stuff plugged in so I can see what you're plugging into your calculator. Okay, so determined your balance for P dollars invested at R for T compounded A, B, C, and D. So you have those parts for each of those problems. You have 6 to do, 7 and 8, and answer those questions. And then we'll start the next video from here.